Are you struggling to build logic and write code even though you know most of the theory about programming? When you studied engineering, did you memorize your lab programs and cleared your lab exam? Here are some useful tips on building ability to construct the logic and algorithm and write good code. Coding is a skill where you have to think each tools that programming language gives you as a Lego blocks. When you look at a problem, you have to break it down into smaller steps, and you have to figure out which Lego block will help you to write code for that particular smaller set of a problem or a smaller problem. Then you need to understand how to organize and assemble it. Whenever you get a problem statement, you need to think in how many smaller parts that can be broken, and then figure out what kind of constructs, what kind of features within a programming language that can be useful. Let's say, for example, you are writing code to count odd and even numbers in an integer array. The way to build logic is, there is an array and you need to iterate through the elements. Whenever you have to iterate through an elements in any data structure, be it array, be it list, you know that you need a loop. The word iterate should buzz in your logical thinking that there has to be a loop. Whenever there is a word where it is filtering out something, then it means there is a condition, and if there is a condition, there will be an if else or a switch statement. And finally, you have to return the output, so there has to be a mechanism to collect the output. The output could be another data structure, or it could be a simple counter, like in this case. Now, since this is a very small program or a very small function, you don't have to break it into smaller parts. You can do this in one single function. You have to have clarity on what it takes as an input and what is the output. Will it return any output, and if yes, what kind of data type it will return the output, or will it print something within the function. Now let's say, take a bigger problem. Let's say, given two strings, you have to find are they anagrams of each other. Now you have to find for each of the string, you have to count for each of the alphabets number of occurrences of that alphabet and sort it, and then eventually compare it. Now you can break this problem into at least two parts. One part which will just take the string, count the occurrences of each character and return back that output to you, and another function which will invoke this function 2 times for both of the strings, and then final logic where it will arrive at the decision. One of the another analogy I use is, what if I have to do this physically in a real world? Let's take the array example. Let's say, instead of array, I have blocks on which the numbers are written and they are organized in a sequence. The condition is that I cannot randomly take them out. I have to go in sequence. So what I would do, I would pick one block at a time, look at the value, make a decision, and write down the counter or increment the counter. So helping to think in a mechanical way first helps you construct the logic. Once you know how to do it mechanically or manually, you can start building the logic. The another important observation is, you have to pay attention to small steps. For example, when I say take a block at a time, it means you are iterating. Check the value, it means there is a condition. You have to see the minute step that your brain is doing in a real mechanical world, because that single minute step also cannot be done by computer by itself unless and until we have programmed it to do it. Programming is one of the important skill for the years to come. Every industry, everything from automobile to banking to manufacturing, everywhere the software is getting embedded. I'll not be surprised in another 10 years from now, people expect you to know programming no matter what role you are in. Let me know your thoughts and comments on this.